Good morning, afternoon, or evening. How you doing today? Welcome back to Mr. Morrow's algebra class. We're going to continue with inequalities today, but we're going to add an extra element to inequalities. Before we were just dealing with single inequalities. Today we're going to learn how to deal with compound inequalities. What a compound inequality means, kind of like a compound word. It's two words together. It's a compound word. Well, compound inequality is two inequalities together on one same number line graph. Okay, you're going to have two different possibilities for this variable that you're solving for. And in a compound inequality, since it consists of two distinct by the way means different, okay? That's different. Two distinct or different inequalities joined by the words and or the word or. When you have an and or an or inequality, you're talking about a compound inequality. Now, how does this work? The graph of the compound inequality with the word and contains the overlap. Please pay attention to that. The overlap of the graphs of two inequalities that form the compound inequality. So, let's take a look at how these two, okay, combine together to become that one. What is the graph of this first inequality that I see? What is the equation to that? Yes, sir. Okay, we got x is greater than or equal to 3. Perfect. What about this next one? What's the inequality for that? Yes, sir. Thank you very much, son. X is less than or equal to 7. Now, if I take this, okay, please try to pay attention. If I take this graph and I meld it in here, don't I have an overlap right here? I'll do that again. This is where it was. This is x is greater than 3, right? This is x is less than or equal to 7. If I overlap them, don't I have an overlap right there between 3 and 7? Well, that's how I create this graph right here. This represents the overlap. And this represents an and compound inequality. It's an and. Sorry about that. So yeah, this is an and compound inequality. Ands are contained within themselves. So how would you read this? This is x is greater than or equal to 3 and x is less than or equal to 7. Okay? You can rewrite this the correct way though. The right way to write this is by placing the x in the middle and reading properly. X is greater than or equal to 3, but x is also less than or equal to 7. Okay? X is greater than or equal to 3, but x is less than or equal to 7. Do you guys remember how I kept telling you, read from the variable, read from the variable, read from the variable? Remember, it was kind of like a broken record? This is why I told you that. When you have compound inequalities, you must put the variable in the middle for the ands, and you have to know how to read and write it properly. It's from the variable. X is greater than or equal to 3, and x is less than or equal to 7. So that means it could be any number between 3 and 7, and including 3 and 7. Does that make sense, guys? Okay. Huh? If they were not equal to, then it would just be x is greater than 3 or less than 7. And it would be an open circle instead of a shaded circle. Okay? So, again, it is read x is greater than or equal to 3 and less than or equal to 7. Does that make sense? Okay. Let's talk about the OR now. The OR. The graph of a compound inequality with the word OR contains each graph of two inequalities that form the compound inequality. Here you're going to have two separate graphs on the same number line. They're not going to intersect. They're not going to have an overlap. Overlaps are for the ands. When they go in their own separate ways, that's OR. Because you can have either one direction or the other direction. Let me explain what I mean by that. What's the equation of the first graph we have here, guys? Yes? Not x would be. No, what is the equation for this? Yes? Oh my God. Guys, come on. What is the inequality here? X is less than negative 2. Excellent. Thank you, guys. Please pay attention, guys. I know that it's early, but you guys got to pay attention, please. What is the second equation? Yes, sir. X is greater than 1. Excellent. Do you guys see how if I were to meld both of these together, if I meld both of these together, do they overlap? No, right? They go in their own separate directions, correct? Well, that's how I get this graph right here. This is an OR compound equation, compound inequality. And it's x is less than 2 or x is greater than or equal to 1. Now, you can rewrite the above compound inequality involving OR as a single inequality as well. You put x in the middle, and x is less than negative 2, but greater than or equal to 1. However, for the ORs, you could do it this way or that way. Either or works. For the ands, you do not have that luxury. For the ands, you have to write it as a single inequality. For the ORs, I will give you the option because mathematically, you do have the option. And I messed that up. Look, I messed that up here. This is x is less than negative 2 and greater than or equal to 1. Okay, there you go. Please make that correction. It's less than. Does that make sense, guys? Okay, now that you can graph it, it's nice and easy. This will be read as x is greater than or equal, and that's wrong. I'm completely wrong here. This is read as x is less than, not equal to, less than negative 2 or greater than or equal to 1. Yes, please make those corrections in your notes, please. This is not the usual way to write the OR inequalities, though. They are usually written, like I said, as that. And again, I screwed this up too. Sorry. This is less than. Okay? So you have x is less than negative 2 or x is greater than or equal to 1. Does that make sense, boys? Excellent. May I continue, gentlemen? Yes, excellent. Okay, number 1. What compound inequality represents the phrase, graph the solution? Okay, all real numbers are greater than negative 2 and less than 6. Well, let's think about that. First of all, the x goes in the middle, correct? And it says all real numbers that are greater than negative 2. So x has to be greater than negative 2 and less than 6. Does that make sense? Now, how do we graph that? Here's my 0, here's my negative 2, here's my 6. X is greater than negative 2, open circle to the right. However, it's less than 6, open circle to the left. So that means it's everything in between negative 2 and 6, but not including the negative 2 or the 6. Does that make sense? You promise, guys? Okay. How about all real numbers that are less than 0 or greater than or equal to 5. Well, in this case, it's an or. So all real numbers that are less than 0. X is less than 0 or greater than or equal to 5. Or X is greater than or equal to 5. If you wanted to write that as a single inequality, you could. X is less than 0, but greater than or equal to 5. Either one of these would work. If it's an and, it always has to be a single inequality. If it's an or, it could be individual or a single. Does that make sense? Yes, sir? Not necessarily. This one could have been the same way too. I could reverse this and go greater than 5, but less than 0. So no, do not go by, oh, it's always this pattern. No, please don't do that. Go by reading. Read it and go from the variable, please. Great question. Thank you. Does that make sense, guys? All right, let's continue. What are the solutions now of BAM? I got -3 less than or equal to m minus 4, which is less than -1. Whoa, wait a second. What do we do here? Actually, really simple, guys. Let's think about this for 1 second, okay? Just for 1 second. If that's gone, okay? Actually, let me make this a little bit bigger. If it was just like this, m minus 4 is less than -1. Wouldn't I just add 4 to both sides and be done with it? Right? You guys with me? Yeah. However, I have another side. So what does that mean? Thank you. Excellent. Whatever you do to the middle to get the variable alone must be done to both sides. So now I have 1, and that's it. M is greater than 1 or equal to 1, but less than 3. Let's graph it. Here's my 0, here's my 1, here's my 3. M is greater than or equal to 1, closed circle, shaded to the right. However, it's also less than 3. So it's between 1 and 3. Is this an and or an or? It's an and because it is contained. Very good. Remember, guys, the ands overlap. The ors go in different directions. Does that make sense, gentlemen? Awesome. May I continue? Okay. So let's bring this up a little bit. All right. What are the solutions of -2 is less than or equal to 3y minus 4, which is less than or equal to 14? You're going to solve for y the same way you have always solved for y. In this case, there are 2 different operations being performed to the y, correct? There's a subtraction and there's a multiplication. What do we get rid of first? Very good. How do you get rid of subtraction? That's add by addition. Very good. So you're going to add 4 to all sides. Thank you. So from left to right, -2 plus 4 is 2, less than or equal to 3y, because the 4's cancel, which is less than or equal to 18. Yes, sir? Oh, sorry. I thought you had a question. Now I want to solve for y. So I'm going to divide 3 to all sides. So I have 2/3. It's less than or equal to y, less than or equal to 6. So y is greater than or equal to 2/3 and less than or equal to 16. To 6. Here's 0, here's 1, here's 6. 2/3 is about here. Y is greater than or equal to 2/3. Close circle. Greater than or equal, I start shading to the right. However, it's also less than or equal to 6. Closed circle. Shaded to the left. They they overlap. That's an and inequality. Boom, done. Sir, very good question. The question was, what if you got to this point, Mr. Morrow, and you had a negative to divide by? The question, which was great, by the way, thank you. When you divide by that negative, do you flip everything? Yes, you flip both of them. Because since I divided by a negative on the left side, that would now become a greater than. They would have to flip. And since I divided a negative on the right side, that would also have to flip. Fantastic question. Yes, thank you. Same rules apply. Multiply or divide a negative to an inequality, you got to flip the inequality sign. Very, very good. Questions? Yes, sir. Yes, we're going to solve some OR ones as well that are compound inequalities. That was the question. Thank you. May I continue, my brothers? All right, let's do this. To earn a B in your algebra class, you must achieve an unrounded test average between 84 and 86, inclusive. That means inside of those values. You scored an 86, an 85, and an 80 on the first three tests of the grading period. What possible score can you earn on the fourth and final test to earn a B in the course? First of all, let's go back in time. We're talking about a test average. An average, if you guys remember, it's also known as the mean, is what? Anyone remember?
All of the numbers added together divided by the amount of numbers.
Excellent, son. The sum of values, excellent. I couldn't have said it better myself. Divided by the total number of values. Very good. Excellent. So, does that make sense, guys? Let's write that down. That's something you're going to use for the rest of your mathematical career. I'm not even joking. They're always saying little average or mean questions, always. So we're going to keep that over there on the side. Now, we know that, let's go step by step. We know that they want your average to be between 84 and 86. So what does that mean? The average must be greater than or equal to 84, and it must also be, guys, they want you between 84 and 86. So the average is greater than or equal to 84, but it's also less than or equal to 86. Is everyone with me so far through the logic that I'm using? Okay. Didn't we just define average as the sum of values divided by the total number of values? So let's plug in. 84, the average. The average here is an 86 plus an 85 plus an 80 plus x on the fourth test divided by 4 tests less than or equal to 86. Does everyone see clearly what I just did there? All I did was set it up nice and easy, step by step. Does that make sense, my friends? What do you mean what happened to the x? The x is right here. That's the fourth test.
Solve it for the variable and divide it through to leave it as x over 4.
Everything here is being divided by 4, son. It's the sum of all values. You have an 86, an 85, an 80, plus the fourth test. Do we know what the fourth test is? That's my x. So I don't understand what you're saying, though.
No, because when you add them all together, wouldn't it be...
It's going to be this added together plus x divided by 4.
What happens to the x?
What do you mean what happens to the x, son? This is 84 is less than or equal to 86 plus 85 plus 80. That's 11, 1. That's 9 and 8, 17. 17 and 8, 251, right? Yep, 251. So I have 251 plus x over 4 is less than or equal to 86. I don't understand what you're saying. What do you mean what happened to the x? The x is the fourth test. You with me? Now, how do I solve for x here, guys? How do I solve for x? Okay, guys, let's think about this. I have a denominator of 4, right? How do we get rid of that denominator? Multiply by 4 to every single side. Do you see this, guys? By now, in our math career so far, we should know right off the bat that if I want to get rid of something in the denominator, I multiply it because I cancel division with multiplication. Does that make sense, gentlemen? Okay, so 4 times 84 is going to be 336. And that is less than or equal to 4 divided by 4. They cancel. So I have 251 plus x is less than or equal to 86 times 4 is 320 and 24, 344. Does everyone see what I did here? Yes, no, maybe, kind of, sort of, guys. Come on, talk to me. Okay, so now how do I solve for x? Subtract 251 to both sides. Very good. So I got a 5, 85, and here I got a 3, and that's a 9. Okay? So I have to get between an 85% and a 93% to have an average between 84 and 86. This is real life, guys. You guys tell me all the time, oh, what happens if I get this on a test? Figure it out. It's an average. Does this make sense, my friends? You understand this? Okay? Next, what are the solutions if 3x plus 2 is less than negative 7 or negative 4x plus 5 is less than 1? In this case, since you have an or, they want you to separately solve them. So I'm going to subtract 2 to both sides. 3x is less than negative 9. Divide by 3. Flip the sign, right? No, good. You did not divide by a negative. So you have that. Or subtract 5 to both sides. Negative 4x is less than negative 4. Bless you. Divide by negative 4. X, flip the sign because I divided by a negative, is greater than 1. Now, how do I graph this? You graph both of these together on the same graph. You have a negative 3 and a 1. X is less than negative 3, open circle to the left. X is greater than 1, open circle to the right. Talk to me, my friends. Does that make sense? Promise? Okay. You sure? Okay. Last one. Okay. What are the solutions if negative 2y plus 7 is less than or equal to 1, or 4y plus 3 is less than or equal to negative 5? It's an or, so we got to separately solve them. Subtract 7 to both sides. Negative 2y is less than or equal to negative 6. Divide by negative 2. Y is greater than or equal to 3. Why did I flip that sign? Because I divided by a negative. Very good. Thank you. Awesome. Next, other side. I got negative 3 to both sides to get rid of a positive 3. I got 4y is less than or equal to negative 8. Divide by 4. Y is less than or equal to negative 2. Why did I not flip the sign there? Very good. I divided to a negative. I did not divide by a negative. Excellent. And now we graph it. I got my negative 2. and I got my 3. Y is greater than or equal to 3, close circle, to the right. Or y is less than or equal to negative 2, close circle, to the left. Does that make sense, y'all? Awesome. Okay, so a couple more now. Now, let's go backwards. Sometimes they give you a graph and they want you to write the inequality, okay? So I want you to tell me the compound inequality, and also for giggles, let's go ahead and define whether or not this is an or an and. So, okay, for A, first of all, they're going in the opposite direction, so it's an or. Very good. How do I graph the equation to this? What's happening? Yes, sir. X is less than 7, correct? Or X is greater than or equal to 11. That is fantastic. Great job, son. How about B? Is it an or an and, my brother? It's an and because it is contained. It's an overlap. Okay, so how would you write this one, my man? You have X. No. X is greater than or equal to 2 because it's going that way.
And then X is less than.
And, good boy, it is less than or equal to 4 because it's going that way. And they meet here in the middle. Does that make sense, boys? Are you sure? Okay. Next, what kind of a graph is this? It's an or. Very good. What's the equation here? X is less than 5. Or X is greater than 7. Excellent. How about for D? What kind is it here? It's an and. Very good. What's the equation? X is greater than or equal to 0 because it's a closed circle. And X is less than 3, open circle. Fantastic. Great job. Make sense? Awesome. Thank you very much. Hope you learned a lot. Have a good day.